So in this video, I will review exponential functions. Okay, so those would be the functions of the form y equals ab to the x. Okay, couple of things to remember. First of all, the a, that is actually the y-intercept. The b, that is the multiplier. And perhaps you remember this from earlier courses. At least that's the hope. Okay, so when we see a situation like this first one, it says, given the equation y equals 4 times 0.75 to the x, describe a situation that the equation describes, then complete the table in order to graph the equation. Okay, so for this one, because this multiplier, or sometimes it's referred to as a growth factor, this is less than 1. So this would be a situation of exponential decay. Okay, meaning something is going down. So for example, now I know that having the 4 here, but let's say maybe this represents, like 10,000s of dollars, okay? So let's say you had a car, all right? And let's say you buy it and every 2 years it goes down by 0.75% of its value. That's not realistic, but I'm just using that as an example, okay? Because let's hope they don't depreciate that quickly, okay? If this was more than 1, so if it was like 1 point something, that would be an example of exponential growth. Okay, so that's kind of some of the basics. So I'm not going to do a specific situation, just kind of in general. All right, so plugging these in our calculator. Okay, so I get about negative 0.71 on that one. Next, I'm going to do the exact same thing, and I'm going to plug in negative 1. Make sure you're using your negative, not your minus key. Remember, it does make a difference. So 5 point, oh, this first one wasn't negative. No. 5.3 repeating. Okay, plug in a 0. Well, do you remember what happens when you raise something to the 0 power? It's like, it turns into a 1. So this is like 4 times 1, so 4. If you don't believe me, go ahead and plug it in, okay? Or if you don't trust yourself, go ahead and plug it in. Okay, if you raise it to the first power, you're going to get 75% of 4, which is 3. And then if you finally raise it to the second power, you get 2.25. Okay, so not a big deal, just plugging in your calculator, right? All right, so now we're going to plot these points. Okay, so negative 2 and 1, 2, 3, 4, 5, 6, 7, a little bit above. Okay, negative 1, 1, 2, 3, 4, 5, a little bit above for the 0.3. 1, 2, 3, 4. 1, 3. And 2, 1, 2.25. So you can see that this is not linear. It's actually starting to curve a little bit, which is what should happen. Okay, remember these are going to be curves that look like this. These also have horizontal asymptotes at 0. Okay, so it shouldn't cross that 0 line, otherwise known as the x-axis, because they do have an asymptote there. All right, just because there's no value that we could really plug in there to get a 0. Okay, so that's the first one. So just kind of reviewing the basics, that kind of thing. Let's take a look at the second one. It says each table below represents an exponential function of the form y equals ab to the x. Complete the following tables and find the corresponding equations. Okay, so these are where we have to try and figure out the pattern and then write an equation. So I actually like to start with the equation, okay, because that will, that will allow me to figure out that pattern. So I actually have 2 points here, right, that I can use. So I have the x and the y, all right? Notice where you're going to plug in the x and the y here. So this first one, 24 equals a, b to the 0. Then the second one, I'm actually going to write it above, and you'll see why in just a second. So 3.5 equals a, b squared, right? So I plugged in x and y. So here we kind of treat this like a system of equations, right? So I am going to take 13.5, divide by 24, and I get 0.5625. When I divide the a's away, they cancel. Remember, when you divide exponents, you actually subtract them. So 2 minus 0 is going to be b squared. Okay, so if I want to figure out b, I'm going to square root both sides. Okay, so on here, I'm going to go second square root, and then I'm going to go of the answer, just because I don't feel like plugging in those decimals. So it looks like the b value is 0.75. Okay, we were actually given the a value. Okay, because look at, I'm going to go back up here. The a is the y-intercept. Well, where's the y-intercept? That's when x is 0. Look at that. This is actually the a value. Okay, so we can write our equation. Y equals 24 times 0.75 to the x. Okay, now what we have to do is just fill in the rest of this table. Okay, so 24 times 0.75 raised to the first is 18. And then 24 times, I don't need the times in there, 0.75 raised to the, what is it, 3? 10.125. Okay. All right, let's do this other one. Okay, if you want to skip on to the next part because you're like, oh yeah, I remember this, I don't need to do another one, that's fine. Okay, so for those of you who want to go through another example. So this one, we have 4 sets of points, right? So just pick 2 of them. Okay, I'll pick this one because zeros are super easy to work with. Okay, so I'll pick this one here, and I don't know, maybe I'll pick the last one. Okay, so I'm going to put the bigger number first, because then again, when I subtract them, then I don't have to worry about negative exponents, because, you know, who wants to deal with those? AB to the 0. Okay, so again, you divide these, right? So we have 3125 divided by 1600. 1 point, I'll just say 1.953 equals, those cancel. 3 minus 0 is 3. Okay, so now to do on these calculators, to do a cubic or a cubed root, you are going to go into the math menu right here. Okay, you can see there's a cube root there, option number 4. Option number 5, that's what will allow you to do like a higher root. Like if you ever need to do like a 4th root or a 5th root or anything like that. So for this one, we just need to use the cube root. Okay, so cube root of, again, I'm going to go the answer, 1.25. So it looks like B is 1.25. Again, we were given the A. It was 1600, right? So Y equals 1600 times 1.25 to the X. Okay, and this table's already completed for us, so we didn't have to do that. All righty, let's see this next set, last couple here. Okay, so this one, it says find the exponential equation for the following. Okay, so here we have another table. Notice it doesn't say fill in the table. We just have to figure out the equation, right? So let's go ahead and review this concept again. So again, I like to start with the bigger exponent just so that when I subtract them, then I don't have to worry about negative exponents. Okay, just a personal preference. If you don't mind negative exponents, that's fine. 7 equals A, B to the 3rd. Okay, so I'm going to divide. Okay, so 15.1875 divide by 27. So 0.5625 equals 5 minus 3. A's are gone. 5 minus 3 is squared. Okay, we actually ended up getting this last time, didn't we? According to the last time we did these same numbers, total coincidence, by the way, the B ended up being 0.75. Okay, we don't know the A on this one though. Okay, so we got to figure that out. So what I'm going to do is I'm going to go back to one of these 2 equations. I'll use this one here. So I'm going to go 27 equals A times 0.75, running out of room. What was that, to the 3rd? Okay, so all I have to do is just divide this over, right? Now be careful, make sure you use parentheses. So 27 divide by, I'm going to go 0.75 raised to the third power, close the parenthesis, looks like 64. So the A value is 64. Now we can write our equation. So y equals 64 times 0.75 to the x. Okay. All right. How about when the information looks just a little bit different? Same information, it just looks a little bit different. This one was in a table. Now here we're just given 2 points. Okay. So again, I'm going to start by setting up my equations, the y equals ab to the x. So I'm going to put the bigger exponent on the top equation. So 91.125 equals ab to the fifth, and then 8 equals ab to the -1. Okay. So again, start by dividing. So 91.125 divide by 8 gives us 11.39. 5 minus -1 is 6. Okay, so I need to take the sixth root of that 11.39. So again, let's review how to do this. I'm going to start by putting in a 6, right? Because I need to tell it what root to give me. Then I'm going to go to the math menu, and I'm going to arrow down to option 5. Okay, so this is telling the calculator that I want the sixth root. Okay, and again, I'm going to go the sixth root of the answer equals 1.5. Okay, why do I do the of the answer? Well, because then it's the least number of times that I need to round, so it's more accurate that way. Okay, all right, now I am going to go ahead and plug in. I'm going to use this top one here because I got to figure out the A, right? So 91.125 equals A times 1.5 to the fifth. Okay, so again, I'm going to go 91.125 divide by, use your parentheses, 1.5 raised to the fifth, close that parenthesis, 12. So it looks like the A is 12. Those are the two pieces we need. So y equals 12 times 1.5 to the x. Okay. All right, last one. This one is very much like the other two, right? But again, it's just presented to us in the form of a graph. Okay, but you can see there are still just 2 points. So again, I'm going to put the one with the bigger exponent, which is the x, on the top. So 2 equals a b to the fifth, and then 1 equals, 5 equals ab to the first. Okay, so 2 divided by 5, that would give me 0.4, right? Yep. So is 0.4 gone. This would be b to the fourth. Okay, so now I want the fourth root. So 4, go to the math menu. We want option 5, so that's the fourth root of 0.4. So about, we'll do this for b. I want to be as accurate as possible. So 0.7953. Okay, 0.7953. Okay, now we need to figure out the A. It's got to be 6 point something, right? According to this graph. So let's see what that 6 point something is. I'm going to use this because that exponent to the first tells me it's going to be a little bit easier to use. A times, can I squeeze all this in? Sure I can. Okay, really tiny, sorry. Okay, so 5 divided by 0.7953, or you could do the answer too. About 6.29. So A is about 6.29, which makes sense. That's probably about right where that is. Okay, so y equals 6.29 times 0.7953 to the x. And there's your review on exponential functions, excuse me.